Hello, everyone, and nice to see you. So let me just share my screen and immediately I will show you what are we going to talk about. So there we go. You should be able to see my screen now. And today we are going to talk about WMI and performance counter discovery and monitoring. So one of the crucial parts of, well, basically any Windows operational system, no matter which version that is, since basically on all of them, those are supported with, well, some exceptions. But first things first, let's start with WMI itself. So for those of you who are maybe new to Windows monitoring, from the perspective of, a deeper Windows monitoring, when you're not just monitoring with the help of, let's say, Zabbix agent, some basic metrics like CPU performance, memory available, space available, and so on, but when you actually need to go deeper. So WMI is Windows Management Instrumentation, which allows you to get any data about the infrastructure of your environment, and not only even one specific, let's say, desktop or one specific server. No, they can actually be used throughout the whole domain to get information about what is in the domain, depending on what user actually is used to make the requests to the WMI. So what can you do is, of course, you can manage the remote computers, but we're talking about monitoring here, so we're not going to do exactly that. But we're definitely going to check out how can we get the information about the system, about the networks, about even the software, about resources that are being used, and so on, using WMI. But of course, okay, now we know that WMI can get us a bit more information or a lot more information. So how to run those WMI queries? And essentially, they are queries. And if a database comes to your mind, well, it's actually not bad at all, because again, the queries themselves are very similar to the SQL queries that you usually, for example, execute to get some information from the database, because essentially WMI has a DB similar structure, and you use WQL or a Windows query language essentially to get information from it. So to execute those queries, you can use WMI-C, but recently, very recently, it actually got deprecated. For example, with Windows 11, or if we're talking about desktop stations, or with Microsoft Server 2022. Why? Because it is, well, considered to be unsafe, since potentially somebody can execute not such a pleasant query. They're still available, you can still use them, but in terms of Zabbix, you won't actually need to. So the best approach to use specifically the correct syntax is using WQL. And for that, we can use Windows PowerShell. Every Windows system has a PowerShell interface. And again, it's quite easy to execute a query through there. We will see examples soon enough. We can also, if we're again already very familiar with WMI itself and how to make the requests, create some scripts, and again, use those scripts to get the data. Or we can use Zabbix agent along with the possibility to do the same, and essentially doing it faster, easier, and in a more efficient way. So how do those queries look like, and are they actually similar to the DB queries that I mentioned? Well, as you can see right here, they actually are pretty similar. And if you know how to build a query, you will get along fine with WQL. But before adding any to Zabbix, to actually making Zabbix agent execute any, of course, it's a good idea to test them out, see what will be returned. And if for some reason you will try to use now deprecated WMI-C, well, the thing is, it doesn't actually use the same syntax as WQL, meaning that you will not be able to use it in Zabbix. So why? Because the syntax is a bit different, as you can see here. Like, for example, product where, name like, get name, version. So it's similar, but it's not exactly a query as we can see in the PowerShell example below, where we just do a select everything from Windows 32 process. It's essentially a table with information about all the processes running on your Windows system. So in case if we would want to get information about a product, we would also go to select, let's say, name, just so select name from Windows 32 underscore product. And you can feel the difference even not seeing that already in just how the requests sound. And if, let's say, you are completely new to WMI itself and WQL2 or WQL, sorry, what you can do is actually you can visit the Windows documentation. For example, they have a lot of very useful examples, which you can just copy paste and start using in Zabbix to actually monitor things. So you don't even need to know this at all. And if you just, use a search a bit, you can actually find a lot of, I would call them top WL queries that I use daily as a Windows administrator to get information. So that is covered in a lot of places, including, of course, those slides. So you can use how to know them in Zabbix. But in case, again, you feel brave enough or you are familiar enough with the query languages, then you can just execute as a first one, get WMI object query, and execute the query, select everything from meta class. And meta class contains basically all the tables with information that you might need about the software installed, about the products installed, about the processes running, about the drives you have on the system, and so on and so on. So basically everything. And no matter which query you execute, you will get something like this, in this case, in the PowerShell itself. So you will get what you request for. So in this case, I requested all the information about the processes. And you can see that immediately I have the name of the running process like Chrome or WebEx host, and I can see what amount of resources it is actually using. This is the information about the software installed. And again, I can see the name of the software, who is the provider of the software, and essentially what version is installed. And all of this can be monitored as Zabbix, be that resource usage, be that inventory information, be that BIOS version. You can actually return it through WMI, and you can then monitor it through Zabbix. So how to get it into Zabbix? Well, first thing we will need is the Zabbix agent, of course. And again, you already know how to install Zabbix agent, so I won't cover that. You have basically already 2 sets of instructions for that. But what I will cover is how to do that with already installed agent. So the first thing you need to know, there are keys, and we will start with the first one, is the WMI.get key, which Arthur introduced. So this key essentially returns the first result, result of the query you will make through Zabbix agent. What you need is the namespace. So where exactly basically you will be going if you have multiple namespaces, and the query itself. So I have an example of query which actually allows you to return the version of the Office you have installed. And you can use WMI.get to actually, monitor the version, see it's updated, or other way around, see it's not updated if it shouldn't be updated, of course. So what do? We do a simple thing. We install Zabbix agent on the Windows machine. We make sure the permissions are right to let it execute WMI queries. Then we configure it for passive and active checks. We can monitor them, the results both ways. So it's up to us. But of course, if you will use, let's say, some long running queries that will require quite some time to retrieve the response, it's a good idea to use them as active checks. And then we create any simple item to return the result, like we see right here. So I'll just close up a bit, and we actually specifically execute the same query. So select version from Windows 32 underscore product, where name like Office, and you will get the version of the Office. So in my case, that was Office version 16 or 2016. But again, that potentially means a lot of queries. So creating a template and a lot of items. How can you simplify your life? You can use WMI get all key, which again returns basically everything that is available from your request. So not only the first object that will be encountered, but again, everything, and we'll return it in the JSON form. What does that mean? That means we, as you can see, this time around, we execute the query with an asterisk, meaning return everything. And this time around, I'm actually requesting to return to me all the processes running on my Windows system. And what I will get in return, I will get the ID basically of all the process and the items themselves. So all the processes that are running, all the exe files, no matter the amount of those. So what to do next? Okay, great. I have JSON. I have JSON that returns me the name of the processes. So what can I do is, of course, first create the item that will get this information into the Zabbix. So the same query, the key, of course, different, WMI get all. It's the type of information now will be text. And as you can see, I will not keep history for it. Why? Because I won't actually need it. I will be using this information, but I will not be keeping this information. And this key will return to me again the information like this. So JSON with the name of the processes again and their respective handles. So now I only need to finish building the items itself. So how do I do that? I actually create a dependent discovery rule. So I have a simple item, as you saw right there, which gets me all the JSON with all the processes. I open the wizard, I click on the create dependent discovery rule and start creating my rule. So key can be custom, it's a dependent discovery rule. And this discovery rule will be by default returning the same JSON. And as you know, and as you can uncover if you don't on our trainings, that low-level discoveries in Zabbix actually require a low-level discovery macro. And this JSON, as you saw, didn't have any. So using LLD macros, I'm actually assigning my own created macro, proc name, to the JSON path name. So essentially what I'm doing is I'm putting every single process name behind this macro. So all is left is to create the item prototype. And this time around, I will use the process.info key, which requires you to specify the process name, just as it was on the previous slides. Then what exactly do you want to monitor? So in my case, I made it simple. For this example, I just specified process name, and by default, this key will return to you the memory usage of the process. And it returns memory in kilobytes specifically. That's why I also added a pre-processing step to return it back to bytes and put units here as bytes so it get converted properly. And as soon as my discovery runs based on this item prototype, it will create an item to monitor memory usage of each process that is running on the system. As you can see right here, all of the items are lighting service, light shot, log app, and so on, Cortana, CMD, everything that is running. Then memory for each process is monitored, so I can clearly see if, let's say, some process will be using more than it should. Like, for example, Chrome constantly does. And if you don't need all the processes, remember what my colleague Arthur said. You can use filters to actually, again, exclude, or other way around, include only specific processes that you want to monitor, to make sure, again, you see and collect only the data that you actually want to see and want to collect. So what about performance counters then? Okay, now we know how to execute WMI queries, where to find examples of those, how we can build a discovery based on those. What about performance counters? So performance counters in Windows is basically, well, just as they are named for, the performance counters, or they count performance, or essentially they show you the performance of each single thing running in your system. Again, those can be drives, those can be drive input output, this can be process, and what resources it's using, can be CPU performance, and so on. And you can view them in Windows in a graphical form anytime you want by using the performance monitor. So if you wish, you can just type it in the Windows search and find it and take a look at it. And it will show you again what exactly is going on. And we can actually do the same in Zabbix without actually needing to go to the performance monitor each time. So we will need to go to performance monitor just once to see what we want to monitor, to find the path, then we create it in Zabbix, and that's it. We can always go to Zabbix to quickly see the performance that we are having on the system without actually needing to go each time to performance monitor and then trying to find all the counters we're interested in. And for that, we have other set of built-in agent keys like perf counter, and you specify path to the counter. And the basically lasts any number of seconds for storing the average value. And as you can see here, perf counter can be also perf counter in or performance counter in English, which is very useful if, let's say, you have a big company, offer offices in different, let's say, countries, cities, and so on. And people there, of course, prefer to use, let's say, Windows in their native language. And from the monitoring perspective, that could potentially mean that you would need to, let's say, specify each performance counter name in the locale this Windows is running, which, when we're talking about doing a massive metric collection, will be time consuming. So to do not have to do this, you can use perf counter in, and again, just specify the performance counter name in English as it is in Windows registry. Another way to actually find all performance counters, if performance monitor, let's say, is too easy for you, you can also open CMD, type in type perf -qx and get the list of those. But again, it can be so big that it actually won't fit in the CMD window. So in my opinion, performance monitor is a easier and a better approach to do that. So how to get those metrics in Zabbix? Again, we will need a Zabbix agent. And then we will go to the performance monitor, and we will click on this green plus sign right here. As soon as you click on it, you will see a window called Add Counters, which in Windows actually adds counters to this graph behind. And here you can find, again, the names of the counters and where they are located. So as simple as that. And then you just use, well, basically the directory-like syntax to point Zabbix agent to collecting those performance counters. What does that mean? So let's say I want to monitor all active terminal sessions on a device. What do I do for that? I go to the Zabbix, I create an item. So I specify the name, RDP, active sessions. Then I use the key perf_counter or perf_counter in if it's a template creation. And then I just specify in a directory-like syntax, terminal services / active sessions. As simple as that. So just as you saw here, terminal services, active sessions, it's basically a copy paste with slashes. And then I just monitor them. And if they are too high, I can create a trigger. Let's say if too many users bombard the poor device. But what to do when we have instances, not just one, not just single, multiple instances. What are those instances? Instances essentially are entities in a performance counter for which the performance is accounted for. And you can see here, there are performance counters for the processors, for each processor you have. So in this case, you can see instances which are, well, you cannot see it here clearly, but you can see there are more than 15. And in this case, it was 16 CPUs that were monitored each for a specific performance counter. So how to get them in Zabbix? Again, pretty simple. So Zabbix agent has a built-in key, which is called perf_instance.discovery. And then we specify, again, the object from performance monitor that we want to get. So in this case, I specified the processor, just as you saw in the screenshot right here. So the processor, and it gives me all the instances. So 16 cores, 16 instances, as simple as that. And this is what Zabbix returns. And as you can see, in this case, the low-level discovery macro is already in the JSON, so you won't need the filters. You will need to just create the discovery rule as it is. Meaning, this is what I have created. So Windows CPU discovery, it's a Zabbix agent discovery, and the key is perf_inst discovery processor. So this one gives me the same JSON as you saw in the previous slides, which shows all the instances with their respective low-level discovery macro. So now I need to actually add an item prototype to monitor how busy each CPU is with, again, user applications based on the information from performance monitor. So I specify that I want to get user time, performance counter, and you can see I'm specifying the path as processor. So the object is still processor, but then I specify which processor. So essentially I do it with an instance, and in the real item, this instance will be replaced with the actual instance from 0 to 15 for 16 cores, that is. And I specify the units are percent. As soon as configuration cache is updated, discovery will run. It will start monitoring the CPU load by user application. So you can see item for each CPU is created, so 16 items, and I see how each CPU is loaded by percentage by the user application. So as simple as that. So thank you for your attention and for, again, being here with us. And I'm ready to answer any questions that you might have for me.
Thank you. We do have one question and one comment. The comment is the type perf qx command. I have to be careful with it because it will give you an enormous list of items, including a bunch of things based on every process and thread running on your system. So yeah, be careful with that.
Yeah, that's absolutely true. I actually tested out on my system and I've never seen the end of it because it was, well, basically endless. So performance monitor, again, is definitely the way to go.
One more question. Is there a specific WMI query or maybe WMI discovery that you have found extremely useful, maybe niche, interesting, or something like that in your own experience?
In my experience, I would say that most of the things can actually be done with the Zabbix agent out of the box. But what is absolutely true that if you want to automate things, WMI queries, especially with WMI.getAllKey, can be very useful to create discovery rules fast and basically find all the entities, like all drives, all processes, all mounts, all software services, and so on.
All right, thank you. And it looks like this is it. Yes, thank you, Aleksandrs.
Thank you.
All right, so that is it for today, for today's meetup. This was the last presentation. So we learned about deploying Zabbix agent. We learned about deploying event log monitoring, WMI and performance counter monitoring, together with automating all of it. You can find more by looking at our documentation, looking at our content in our blogs, in our YouTube videos, and of course, our training content. So stay tuned for more meetups. We'll have more meetups focusing on different topics soon in the very nearby future. If you have some suggestions, if you have a topic that you wish for us to discuss in a meetup, feel free to leave a comment on forums or Reddit or in YouTube.